Hello guys, welcome once more to another video on our YouTube channel. So in this video we are going to look at the Southwest Regional Mock Paper 2 question 1. It was from differential equations, specifically second order differential equation. So the question reads, find the complementary function of this differential equation in the form y equal to f of x, and then you find a particular integral and a general solution also in the form y equal to f of x. So to solve such equations, we begin by finding to get a complementary function, we must start by stating the auxiliary equation. In this case, if I introduce a parameter m, then my auxiliary equation will be m squared minus 4m plus 4 equals to 0. Those of you who have never studied differential equations, I think this concept is new to you. So in the next video, I will do a brief summary of the topic. But those of you guys who have studied the topic before, I believe you understand why this is a complementary function. Anyways, I'm just going to explain a little bit so that those who are new to the topic will get the concept behind the auxiliary equation. Okay, so to get the auxiliary equation, all you need to do is you have to replace, basically all you need to do is you have to replace the squared y by the x squared with a parameter squared. If there was a constant here, you also need to put a constant. Also, you need to replace the y by the x with the parameter, and you need to replace y with a parameter to the power 0, which is just 1. Okay, so here we see there is no coefficient of the squared. The coefficient of the squared y by the x squared is 1. That's why I just have the parameter squared. Yes, now there is a minus 4 here. Okay, so that's why I need to take minus 4 times the parameter, and here there is 4, so I need to take 4 times the parameter to the power 0. But the parameter to the power 0 is just 1. That's why I just have 4. Like I said, in the next video I'll try my best to explain to you guys. Okay, now you need to solve the auxiliary equation, and the nature of the roots of the auxiliary equation will tell you more about the complementary function, the exact format of the complementary function. So to solve this quadratic equation, we can identify that this quadratic expression is a perfect square, which is m minus 2 all squared. And when we solve, we have m equal to 2, and it is a repeated root because it is all squared. So we have m equal to 2 and m equal to 2. So we'll just write m equal to 2. And when the root is repeated, the complementary function has its form. The form is ax plus b e raised to the power that root times x. The root is 2. That's why we just have ax plus b e raised to the power 2x. A and b are real constants. Okay, so that is the complementary function, and we are done with the first part of the equation. Now the next part is asking us to get a particular integral. So the particular integral will always depend on the right hand side of the quadrant of the differential equation, and the right hand side is 3e to the minus x. Okay, so the particular integral will be in the form a constant e to the minus x. 3 is a constant. Okay, so like I said, it's going to follow the exact form. But whenever we have this initial guess as a particular integral, we always verify if this particular guess is always part of the complementary function. Okay, if it is part of the complementary function, we now multiply the particular integral by an x and we verify again. Anyways, in this case it's not complicated because it is not part. In the next video, I'm going to do series of examples where we are not just going to use lambda e to the minus x, but we are going to do something with it depending on what we have as a complementary function. But in this question, we just move on. So having the particular integral's initial guess as lambda e to the minus x, there's something you have to note. You have to know that the particular integral is always a solution to the differential equation, which means that its second derivative minus 4 times its first derivative plus 4 times itself should always give us 3e to the minus x. That's the meaning of something being a solution to this particular differential equation. So I need to differentiate the first and second time, then I replace it here and I get the value of lambda. So my initial guess is lambda e to the minus x. When I differentiate it with respect to x the first time, I get minus lambda e to the minus x. When I differentiate this first derivative the first time, or I differentiate the function the second time, I get lambda e to the minus x once more. Okay, so with that, we have to replace the particular integral, its first derivative and its second derivative, back into the differential equation. since we know that this particular integral always solves the differential equation. So doing that, we just have to replace the second derivative with what we have above, the first derivative with what we have above, and itself with what we have. Then we simplify to get 9e to the minus x will be equal to 3e to the minus x. E to the minus x cancels, so we get 9 lambda to be equal to 3, and lambda will give us 1 divided by 3. Now, lambda giving us 1 divided by 3, we can deduce the particular integral as 1/3 e to the minus x by just replacing lambda with 1 divided by 3. Now, the general solution is the sum of the particular integral and the complementary function. So I need to take my particular integral and I sum with my complementary function. I get my general solution. Thank you guys for watching. See you in the next video and stay tuned.